Good afternoon, dear students. Today let's discuss about capacitors. Before discussing about the capacitors, you have to know one thing about how to charge a conductor. So let's first discuss about how to charge a conductor. So in order to charge a conductor, so whenever generally conductors are metals, therefore whenever a charge is given to a metal, the charge resides on the outer surface of the metal such that net electric field inside the metal is zero. For example, if I take a metal body of irregular shape like this, for example, then whenever a charge is given to this metal body, the charge will reside on the outer surface such that net electric field inside will be zero. So how a charge will be decided, how a charge will be distributed on an irregular body? The charge will reside in such a way that the surface charge density sigma is always inversely proportional to the local radius of curvature 1 by r. Therefore, whenever a charge is given to a irregular shaped body like this, the charge will reside on the outer surface in such a way that in the sharp edges the percentage of charge will be more and it will be less at these surfaces where the radius of curvature is less, like this. So the charge conservation will be of this manner. Okay, when it is very sharp, the charge concentration will be more and it will be less when surface charge density is less. So the charge will be distributed in such a way that the surface charge density sigma. What do you mean by surface charge density? The charge present on the body per unit area is called the surface charge density. So the charge density per unit area is called surface charge density, and the surface charge density will be inversely proportional to the radius of curvature. So the charge will be distributed in this way. So for example, you are asked to charge a conductor. So the charge up to which it can be, every conductor can be charged up to certain quantity of charge. So why there is a limitation to the charging of a conductor? That's the general question rising. So in order to answer this, we should think in this manner. Okay, see, so as this body is placed in a medium, so the medium is made up of, generally the medium around the conducting body will be an insulator. So whenever an insulator is considered, so all the insulator is made up of molecules, for example air. Therefore the molecules which are in the air, for example like this, these are the molecules. So whenever these molecules, whenever a charged conductor is placed, the molecules will transform into dipoles such that negative value is being attracted, negative charge is being attracted, and positive charge will be residing in the outer surface in this manner. So negative charge will be towards the surface, towards the metal body, and positive charge will be away from the metal body in this way. So whenever you increase the charge on the metal body, what happens is that whenever you increase the charge on the metal body, that due to the increase in the charge, there will be the dipole distraction will be very more. So it goes on breaking the separation between the positive charge density and negative charge density will be increasing, and finally there comes a time that there will be breaking of the molecule. Whenever a molecule breaks that, the charge will transform into the negative charge will travel towards the metal body, which makes ultimately the entire medium to be conducting. Therefore until which there is a limitation, until which this breaking force, therefore when the electrostatic force of attraction EF will be equal to the breaking force of the dipole, then the entire medium converts into a conducting medium. Therefore from then what happens, the charge on the metal body, so electrons comes towards these electrons which are coming away will come towards the metal body, and the charge on the metal body will be decreased, and finally there will be ultimately a limitation up to which the charge can be placed. So this is called the maximum capacity up to which a metal body can be charged. As this is a metal body, the maximum capacity up to which a metal body can be charged is called the capacitance of the conductor. That is the way how we describe the capacitance of a conductor. So therefore, what ultimately, now you can see that where is the first breaking force will be applied, where the first molecule will break. See, as the surface charge density is very large, therefore the dipole first breaks at this point. So minus and plus, this will break it here. So if it breaks here, the electron will be moving forward. Therefore, the main braking force and the charge of the conductor to which it can be charged depends upon two things. One is the shape of the conductor. The first one is the shape of the conductor, and the other is that the dielectric of the medium, dielectric constant of medium. How this will be, how both of this shape of the conductor and dielectric constant of the medium will show the effect on the metal body. See dear students, if first let's discuss about the shape of the conductor. So if you consider this metal body, you can find here that as the surface density is very more, as due to the sharp edges, therefore the braking force will be more. If there are no sharp edges, then the charge up to which it can be charged will be more. Therefore, it depends upon the shape of the conductor. And what about the dielectric or the constant of the medium? So the dielectric constant, how it will show its control on the metal body charging. See dear students, so for example, if I am having a very strong insulator, then the force required, the braking force will be more. If the braking force is more, then ultimately the chance to form the conducting medium will be less. Therefore, there is a more chance for the metal body to get charged. So that is why it depends upon the shape of the conductor as well as the dielectric constant of the medium. Understand? Therefore, let's discuss about how to change. If we have discussed about the charging of a conductor, now let's discuss about capacitance of a conductor and the analytical formations and the analytical analysis regarding the capacity of a conductor, as well as what is a single body going to become a capacitor, or can 2 or 3 conductors can act as a medium, as a system to form a conductor, to form a capacitor. Let's discuss about these things in detail in the next chapter.